Good morning. So in today's lesson, we are going to be talking about virtual private networks and some of the more technical aspects of virtual private networks. We have studied about virtual private networks in some of the previous courses in networking. And in today's discussion, it will be more around some of the security aspects of virtual private networks and how we go about implementing secure VPNs and some of the technologies, protocols involved in setting up that. In today's lecture part, I will be covering most of the technical foundations, but in the slides that is shared with you on LMS, there are some additional information about the implementations or configurations of VPNs and some of the steps involved in that. I think possibly some of those things can be covered in one of these upcoming practical sessions that will be done by Mr. Surat. So if we go back to the basics of VPNs and why we want to use or why we use VPNs in most enterprise environments, there are a number of benefits that we get from using VPNs. So essentially, the main thing that we use VPNs are for remote connectivity, but on different circumstances. So it could be a remote connection to a remote or like a regional location or a branch location kind of a situation. Say, for example, in the case of a university, we can have remote VPN connections between two different faculties in two different physical locations. For example, the main university and one of the faculties in a different physical location can have a VPN connection. There can be VPN connections between like a home environment. So like an employee who is working from home may be connecting to the organization infrastructure through a VPN connection. So that is another possibility. Sometimes we may establish a VPN connection between our business partners. Say, for example, we have a bank, and then bank also works with some other banking financial system, like say a credit card processor or something like that, where they need to have some connectivity, and that connectivity will be done through an established VPN connection that exists between these business partners. So these are sort of main scenarios under which we may be using VPNs. And when we think about these scenarios, the reason why we go for VPNs rather than having, say, dedicated connections between these entities is because there are significant advantages of cost savings when we compare to having a dedicated line connecting between these sources or these entities. Then, as an alternative to using connecting through the internet, again, when we use VPNs, they can be much more secure because we will have a dedicated tunnel for communicating, a secure tunnel for communication compared to going through the open internet. Then we also have advantages when it comes to scaling up enterprises or scaling up businesses. So then again, like depending on our needs, we are able to scale up to a different environment using VPNs. Say, for example, when we think about the pandemic scenario, when a lot of organizations had the need for their employees to work from home, one of the things that happened in that environment is the organizations that had established VPN setups were able to quickly enable their employees to work from home without compromising on security. So they were able to scale up their remote workforce much quickly because they were able to establish these secure connections and enable employees to access the internal systems without any issues. And also, when we think about such sort of disjointed network of organizations, for example, if we take in the context of Sri Lanka, when we take all the universities are part of the network called Learn. Learn is the network that interconnects all the universities. All the internet provision comes from Learn, and uh, all the universities are also interconnected through that network. And that is essentially a VPN type interconnection between organizations, these educational organizations, that is running on top of a backbone provided by an existing internet service provider, in this case SLT. In most places it is SLT that is providing the backbone, and on top of it, Learn is providing these VPN connections between all the entities and then to the internet as well. And that also extends not just within Sri Lanka, it also interconnects a number of educational organizations in Asia and elsewhere as well. So there are a number of these interconnections happening in that way as well, utilizing VPN technologies. So then when we take all these scenarios, whether we are connecting to branch offices, whether we are connecting to mobile users who may be working from various places, or even if we are thinking about users who are working from home office type environments, who are always working from there, all these people are still connecting through the internet. So internet is going to be the backbone of these virtual private networks. So to do that, the technology or the set of protocols that we use are protocols that are on the layer 3 of the OSI layer. So OSI layer 3 protocols, or that is where we implement VPNs. And the main framework of protocols that we will use for secure VPNs is called IPsec. So that is the one that is going to provide the capabilities to establish secure interconnectivities between our networks. So with that, when we think about the type of VPNs that we can have, there are two main categories, or we can categorize them as two main categories of VPN connections. One is known as a remote access VPN, and the other one is known as a site-to-site VPN. So a remote access VPN is when a client, say for example, you are a mobile user, you are connecting from your laptop, you will normally initiate a connection to your VPN server on your organization side, and you will establish a connection, and then you will use that connection when you need to use it, when you need to access any of the organizational resources, the systems or software that is running only inside the organization network. You will establish a VPN connection and use it. And then at the end of that thing, you may terminate that connection and go. When we talk about a site-to-site VPN, this is essentially a type of VPN connection that is always established between the two entities. So here we will normally have a router or a VPN, a device that is able to establish this VPN connection and keep it running all the time. And then we will connect to that device. So for example, if you can have a home router or router at your home device, at your home, a device that can establish VPN connections, and then you have an organization that can again support these VPN connections, you will create that VPN connection between these two devices, these two networking devices, and they will always have that VPN connection active between those two entities. Then whenever you need to communicate, you will connect to that router, and that will, all your connections will go through that VPN connection. So that is a site to site VPN. So the main difference here is these connections are always established and always there, compared to remote access VPN, which you would normally use only when there is a need for VPN connection. So that's the main difference. So especially when we think about the previous scenarios of sort of different types, say if we think about a mobile user, there's most likely that it would be a remote VPN connection. But whereas when we think about something like a branch office, or sometimes even a small home home office type environment, or even a business partner type VPN connections, these would be more likely site to site VPNs that would be always active, and always the traffic will go through the VPN connection. So this is something that we can establish depending on our needs. So most of the remote access VPNs are much easy to start with, because most of them, it is a piece of software on your client side that establishes connections, and that is fairly easy to set up as well. Whereas for site to site VPN, most likely we will need additional infrastructure, some devices that is able to do that part at the client end and the receiving end as well. So if we particularly think about the remote access VPNs, here the main entities are going to be the client side. So that is going to be the mobile user from a laptop or even from a mobile device. And at the organization side, we should still have the VPN terminating device, or a device that is able to accept these VPN connections. And all the connection will go, the backbone could be the internet. So you are still connecting through the internet, through your internet service provider. So that part will be the same. But on your client side, you are most likely to be having a software, so something like Cisco Ready Connect, or there are various software or OpenVPN clients, or various things that you can have that are able to establish these remote VPN connections from these devices in the form of software running on top of standard end user operating systems. So in most cases, when we think about remote working in this scenario, this is the type of VPN that we will have. Most people will connect through these type of software-based VPN clients on the client side to the organization. But when we think about site-to-site VPNs, again, there's a prevalence, particularly not much in the Sri Lankan context, but in some other places where there may be employees who always work from home. There are people who always work from home. They don't particularly come into the office to do their work, so they always work from home employees. So in such scenarios, sometimes they may have dedicated VPN devices from their home environments to establish VPN connections. But this is more common between site to site, between branches and head offices, or say faculty and the main university in a university scenario, to have a VPN terminating device at both ends, and both of those will establish and keep active VPN connectivity, and all the traffic will be routed through these terminating devices when it is between these two sides of the network. So main difference here is, here the end user devices don't have to have any additional capabilities or any additional software or anything like that to enable the possibility of having VPN connections. So you can just connect to the network, like to your Wi-Fi or LAN connections or whatever, and the traffic will be automatically routed through the VPN terminating device to the other end of the VPN, and to the internal network of the organization, and vice versa. So that is the main way that we would establish and have uh, site-to-site VPNs. So when we think about these secure VPNs, so whatever things that we discussed, whether it could be a site-to-site VPN or whether it is a remote VPN connections, we need to have some secure technologies to implement these VPN connections. There should be a technology framework or technologies or protocols that we need to implement that. So the main sort of common technology framework that we have here is known as the IPsec framework. So IPsec framework is not a single protocol, but rather a set of protocols which can be used in sort of different combinations at different implementations. So you can implement it depending on your need. You can choose between different protocols and create a combination of protocols that you want to use in your environment. Say, for example, what you can have is, say, in an IPsec framework, you need to have a number of different protocols. So you need to have the initial IPsec protocol, the overall IPsec protocol. Then you can have something for confidentiality, something for integrity, something for authentication, and something for key exchange. So you can make a combination of these for your own implementation. Say, for example, here you see two different implementations or two different sets for implementations. So you can use, say, for IPsec or ESPNH. We'll look into each of these in a bit more detail. Sometimes you may not have something for confidentiality purposes, whereas you will have something for integrity, something for authentication, something for Diffie-Hellman key exchange. So you can have different sets of protocols, and a combination of these protocols is what we would identify as the IPsec framework. So if you look at each of these things, so these are things that you would have covered. We would have covered in some of the other security courses as well, like confidentiality, integrity, and how we achieve that. So here, when we think about confidentiality, the main aspect or the main thing that we use to achieve confidentiality is using encryption. So here we'll have to have some encryption and decryption at both sending and receiving end, and some form of key to do the encryption. So whatever the message that is going to go through the VPN will be encrypted at the client end, and I will be decrypted at the recipient end. So when it is going through the internet, now it is only something that is not intelligible. So it gives confidentiality through encryption. So that is one of the building blocks of IPsec. So again, for confidentiality, we can have different encryption algorithms. So again, we have discussed about DES and 3DES and AES. So there can be different security levels we can achieve with different encryption algorithms, and the level of security that we can get from these can differ depending on the algorithm that we choose. So again, depending on our VPN requirements, we may choose one of these to establish our IPsec framework. Then for integrity, again, integrity is again, as we have discussed previously, we get through hashing. So again, another cryptographic concept. where we create secure hashes using hash algorithms, and then that provides the integrity part with the in addition to the confidentiality part. So again, for this we can use either MD5 or SHA, and these days SHA is much more preferred. So that is something based on which is more secure as a hashing algorithm. So again, the message that when it is going through uh, the common communication channel through the internet, for example, again, it could be protected against any any intentional or unintentional modifications. Then another part that we can have is about authentication, because again, when we have two entities needing to communicate, establish communication between two ends, we need to have authentication between the two entities. So again, we'll have to have some cryptographic based authentication protocols that can establish their identity and authenticate the users at both ends. So again, we can have different authentication mechanisms to authenticate the entities at both ends. So for example, we have discussed about RSA previously in the previous course, where we can use the private keys and public key to establish authentication and verify the authenticity of the user. So you encrypt with your private key, send the signature with the digital signature with the certificate, and it is verified at the receiving end, and because your public key is available at the recipient and it can be established. So authenticity can be established. Again, here we can choose what we want to have as part of that component in our IPsec framework. Then one of the most important parts of this communication is what is known as the key exchange. Because when we are establishing a secure connection, both entities don't have an established secure connection until that secure connection is established. So for us to start a secure communication, we need to first start through an insecure communication. Because say when I need to establish a secure connection with you, I will be starting at a point where we don't have a secure connection yet. Only after it is established, we will be able to say, okay, now we have a secure connection. So how do we go about establishing that secure connection from a point where we don't have a secure connection? So that is where we have key exchange protocols. So the most common key exchange protocol that is most commonly used is known as the Diffie-Hellman key exchange. I'm not sure whether we have discussed this previously in the security course. We are not going to go into much detail into Diffie-Hellman today, but I will share some additional resources that you can refer to get a bit more understanding about Diffie-Hellman specifically. But what you need to understand in this context is we will have to have some protocol that is able to start from an insecure connection and go to a secure connection, still establishing that secure path. So that is where we have Diffie-Hellman, and there are a number of variants of Diffie-Hellman, again with different security parameters or security outcomes. So we can choose one of those and use that. So in addition to these sets of protocols. So things for confidentiality, integrity, authenticity, and authentication and key exchange. We will also have an overarching, we'll need to have an overarching protocol that is going to manage all these things, because these are individually different things, but all these things have to be combined and managed together to establish that VPN connection or VPN communication. So to do that, we will use the IPsec protocol. An IPsec protocol would be something that can combine these things and establish that connectivity. And again, for this, we have a number of options here, a number of options to establish this. So we have what is known as the authentication header protocol, and we also have the encapsulating security payload. So these are again two different protocols that we can use as part of the IPsec protocol, and combined with the other protocols at the other layers for confidentiality, integrity, authentication, and Diffie-Hellman key exchange, that combination is what we would identify as the IPsec framework. So now we'll briefly look into each of these IPsec protocols, because the other things are things that we would have covered previously in the security courses. So today we will mainly look at the IPsec protocols and some of the specificities of these protocols, the authentication header and ESP. So authentication header protocol is again, if we use these other protocols and the connection is still going to be, so if there's nothing, the connection is plain text communication between two entities. So then we can add some of these layers to add our add sort of additional components, so additional secure components to our communication. Then what we have is, with authentication header, we will have an additional piece of information. So this additional piece of information would be, so we will have the typical IP header, so that part will be there. Then in addition to the typical IP header, so we have, so normally if there's nothing, normal communication, there's an IP header and a data, and that's it. So with authentication header, what we add is we add an additional layer. So that is why we don't have a confidentiality part here, because we have, when we use authentication header, we don't have a confidentiality part. The communication is still plain text, but we can have integrity authentication and key exchange components can be included. So then authentication header will only add the integrity part. It will add the hash, it will create a hash and include that as the authentication header. And at the receiver's end, that hash can be verified to see if the received communication is received without any modification. So we can check for integrity. So checking for integrity is possible with authentication header, but it is not supporting checking against confidentiality. So when we think about it, in today's usage scenario, something like authentication header is not very useful for us, because we don't want plain text communication between entities. We want them to be encrypted. We want confidentiality as well. So this is where we have the ESP, or the encapsulating security payload. So here what we have is, we have the confidentiality layer also included, and we have integrity authentication and key exchange as well. So with ESP, what we have is we have the IP header and the data. So that is the normal communication that we have between two entities. We have the IP headers, we have the data, that is what is sent and that is what is received. So here that part is the same, nothing changes with the typical IP header and the data that is received or sent, that part is not changed. But what ESP adds is ESP will add an additional ESP header, and it will add an additional, so it will first add an ESP trailer, and then it will encrypt the whole thing including the IP header and the data. Then it will add an ESP header, and then that whole thing will be authenticated. So there will be hash created for the whole thing, and that will be added as ESP authentication at the end. And this new whole thing will have a new IP header. So what we're having is, in the previous one, we just added an authentication part, authentication header, and we just communicated with that. But whereas with ESP, we add the confidentiality and authentication, and then send the whole thing as a new piece of packet through our communication channels. So with ESP, we have two different options as to how we can implement ESP. One is known as a transport mode, and the other one is known as a tunnel mode. So in the transport mode, what happens is we only encrypt the data. So whatever the normal part of the packet, the data part of the packet, we take the data part, we add the ESP trailer and encrypt that, and then we do the authentication with the ESP header, and then we use the same IP header to send the communication. The IP header doesn't change, we send that. In the tunnel mode, what happens is we take the IP header and the data, leave it as it is, don't do anything, add the ESP trailer and encrypt it, then add the ESP header and authenticate it, include the ESP authentication, and add a new IP header and communicate. So these are the two different ways that we can implement in ESP mode. The two different modes we have with ESP. So again, when we have ESP, so again between ESP transport and ESP tunnel, again, particularly when we have site-to-site VPNs, we will essentially have tunnels set up. So that will be like that. When we are using say remote VPN connections, depending on the way that we implement that, there's a possibility that we may go for a transport mode as well, but we can set up tunnel modes also in such scenarios. So as you can see, ESP tunnel is particularly much more complicated or involved compared to something like an authentication header, because authentication header is a fairly simple protocol which just adds an authentication header through compute the hash and just adds that authentication data as part of the authentication header. Whereas tunnel, particularly the tunnel mode in ESP, is much more involved as a protocol. Then one of the things that needs to happen when we are using when we are using these using an IPsec framework, is these two entities, the local and the remote user, or the local peer and the remote peer, they need to negotiate and identify what are each of these things that they are going to use. So what is the IPsec protocol they are going to use, what is the confidentiality protocol, what is for integrity, what is for authentication, and what is for key exchange. So they need to specify, they need to negotiate and establish that part first before they can start communicating. So that will happen. So that is in two parts. First, they have to do the key negotiation, because before anything can happen, they have to first establish the secure tunnel. So they have to negotiate the key exchange. So they will have to do the Diffie-Hellman key exchange. They will first negotiate the policy. So that is saying what is the framework that they are going to use. So what are the different things as part of the framework. So one end will have to send that, and other one will have to acknowledge and accept, or they have to negotiate and change, come to a common understanding. Then they'll have to do the Diffie-Hellman key exchange, and then they'll have to do the verify the both entities once the key exchange has been completed. Then after that, they will again go into negotiating specific IPsec policies. So that is that negotiating that specific IPsec parameters is known as establishing security associations. So again, that is the next step that will have to happen. So again, when we go into the technicalities of actually implementing these, we will not really go into the specificities, because these are some of the configurations that we do, particularly what are the things that we accept at our end, and then the remote will have configured something, and if those things are agreeable, the protocol will communicate and negotiate and come to an understanding. So that negotiating parameters and establishing the security associations will be done through the IPsec protocol. So now we will briefly look at what are the steps involved in establishing and configuring a site-to-site IPsec VPN. And as I said, the specificities of configuring the configuration things could be covered in one of the practical sessions later on. So when we think about configuration, we'll first look at what happens when an IPsec communication is established. So it will start with one of the hosts that is initiating will need to send some traffic. So it will start from that. So the host is the one that is going to start sending some traffic. But then after that, when that communication needs to happen, the routers that are involved between these two entities will have to go into the phase one of negotiation to establish the parameters. So the phase one is where we have we do the policy negotiating the policy, doing the key exchange, and verifying the identity. So these are the phase one steps. So first, that will need to happen. Once that has happened, then it can go into the phase two of the establishing phase, the VPN negotiation phase, which is where we do the IPsec parameters. So where we get the security associations. So again, that would be the phase 2. So once those two phases are completed, now we have an IPsec tunnel established, and all the secure communication can go through that secure tunnel. And once, say for example, if it is to be terminated at that point, that would be the last step. So when all the communication are completed, the tunnel can be terminated if it is not to be maintained any further. So if we particularly look at the overall topology of establishing a site-to-site VPN, we will have the hosts at our organization at one end. So we'll take, say, two sites are there. So if we take the university, one would be the main university premises and one would be a remote faculty premises. And at both ends, there will be local area devices in both ends. And then both ends are connecting through routers through the internet. But at the routers is where we will add the VPN component. So at the routers, anything that is going out could be routed through a VPN connectivity. So that VPN component will operate at these end routers. So those end routers should be capable of supporting those VPN protocols that we want to implement. So the various IPsec protocols, depending on what we choose, should be supported at both ends, the devices at both ends. Then we can establish such VPN connections. So if we look at the specifics of configuring these things, we can look at a number of steps. Say, for example, when we look at the security policy of the organization, we will have certain things. Say, for example, we'll say the security policy will say for encryption, we will use AES 256 and we will use SHA for hashing. Then it will say for authentication, we will use PSK. It will say for key exchange, it has to be group 24 key exchange. Then for the IPsec tunnel, it is only valid for 1 hour. So every 1 hour it has to be renewed. Then if you are using ESP, that each IPsec tunnel is only valid for 15 minutes. So we'll have number of these things as part of the policy. So then when we go into configuring these routers, at both ends of the routers, we will have to specify these things individually. So we have to say what is the policy for phase 1, what is the policy for phase 2, what is the policy for cryptography. So and then we have to configure and set up these things at both ends. So then only they will be able to establish a compatible connection between the two entities. So in addition to this, like say, you may also need to allow certain additional things through ACL, for example. Again, access control list. So again, things we have covered previously. So because we establish some additional connections, so these connections are going to be beyond our standard communications. These should also be allowed as part of our communication. So if you are using ESP, that should be allowed specifically. So some additional permission should be given so that all the IPsec specific communication can also happen in our network. So once we can combine all of these things, there's another way that we can establish this is known as what is known as a generic routing encapsulation. We are not again go into detail into this in today's discussion, but that is something that again I'll share some additional resources that you can refer to get a better understanding. But again, GRE is another way of going about this. But here, what happens is, in addition to the original packet, we add another GRE header and an IP header, and it's a slightly different way of establishing a tunnel. So it's again another way of establishing a tunnel connection between two entities. It for today's discussion on IPsec. You will be we'll be covering some additional aspects of IPsec in IPsec and setting up VPNs in practical activity. I'll discuss with the lecturer and confirm when that will be done. And I will also share some additional resources relevant to some of the topics that we discussed today, so you can refer to some more advanced concepts in that. So that is mainly it for today. Are there any questions on that, on things that we discussed? If there are no questions, we may conclude today's discussion, and we will continue with another lecture later on, and there will be some additional practical sessions as well. The schedules will be shared to you later on. Thank you for joining today.